Okay, did everybody get notes? All right, so just again to recap, 3 pieces, right? 3 parts we decided it will work to make a congruent triangle. We used only angles and sides, right? So let's come up with all the different possible combinations. That I can use the letters A and S, but I have to fill 3 blanks. So think what we got. Yep. Okay, so 2 angles followed by a side. Good. What else? We had side, side, side. So if you do all 3 sides, you can make my triangle, right? What else? Yes.
Angle, angle, angle.
Angle, angle, angle. Good. What else? Go ahead.
Angle, side, side.
All right, someone had to say it, right? Okay, what else?
She must be the imposter.
Go ahead.
Side, angle.
Okay, so we had 2 sides and the angle in between them, and then we should have one more. SSS. There we go. Okay, so this is all the different ways to combine angles and sides in groups of 3, right? Okay, so we talked about why angle, angle, angle doesn't work, right? It's just like clip art. Okay, so think about if I have clip art and I want to double it in size. Okay, so let's pretend I accurately doubled this in size. The height of the door here started as 6 inches and now it's 12 inches. And then the height of the window started as 2 inches and now I've doubled it, now it's 4 inches, right? So let's focus on the door for a minute. If I truly doubled it, keep that in mind. My door here is a rectangle. What's the measure of the 4 angles? 90 degrees, right? We have good carpenter, hopefully it's 90 degrees. So when I doubled my clip art, what's the angle measures on my door? 90 degrees. So my angles don't change, right? No matter the size of the door, if it's a rectangle, I should have 90-degree angles. No matter if it's a little teeny tiny door or a really big door, right? Okay, so angles, when you change the size of the triangle, don't change. They remain congruent. So we can't base everything on angles in order to make congruent triangles. So that's why angle, angle doesn't work. Angle, angle, angle doesn't work. All right, so let's talk about the infamous angle side side here. When we were doing constructions, you did a problem where it's at the bottom of a worksheet. You were drawing triangles that day, like I said, like this angle is this much, this side is this length. You were drawing very specific triangles for me. At the very bottom, I gave you an angle to copy. Let's call it angle A. I gave you 2 side lengths then. So I gave you like AP and, I don't know, I gave you like PR, whatever it was. Okay, so you copied your angle first. So we made a copy of our angle. And then I set my compass length, that's angle A. I set my compass length to AP. So we took our compass and we swung an arc to represent where P was going to be. And then we set our compass length to PR. We put our point there. And what happened was you swung an arc. And that arc intersected that side twice. Remember I said I asked you to make 2 different triangles given these 3 parts that angle those 2 sides. Is it ringing a bell a little bit? So then what happened was I could draw my triangle like this. So R could be here or R could be over here because PR, both of those are PR. So the question was then, which triangle was it? Was it this little skinny PR or was it this overall bigger triangle APR? Is that kind of ringing a bell? This is an example of angle side side. You might get lucky and choose the right triangle, you might not. There's only one scenario where it works, and that's when you have a right angle. Okay, so let's think about this for a second. If I started with the right angle instead of just some random angle, if I have a right angle, I can still copy. There we go. I can still copy my segment length here. Right, that would be AP. When I swing my arc for AR, it would go like this. And what ends up happening is I have agreed, and now this isosceles triangle. Here is my right angle. So these two triangles end up being congruent to each other. So then that's why it doesn't matter. Because you have that right angle and you end up with these two being congruent, so either side ends up giving you the exact same triangle. But we don't like to call it angle side side for obvious reasons. It's referred to as hypotenuse leg. I know, it's disappointing. So it's referred to as hypotenuse leg. So if you have a right triangle, this only works with the right triangle, you know a leg and you know a hypotenuse, then you can duplicate it. Again, it's the only time that works is if it's a right triangle. Otherwise, you end up getting two different possible triangles. And sometimes you're lucky and sometimes you're not. Okay? So it doesn't consistently work unless it's a right triangle. So to help you remember, you're not allowed to swear in school. Can't use angle side side. Okay? You can't use AAA, trademark by the American Automobile Association. Right? So we're left with everything else. So I gave you a list here of all the different combinations. Now, make sure we need to understand the difference between really these three here. So understand, if I say side angle side, we're talking about two sides and the angle that is in between them. Because the A literally sits between the two S's. Right? Like literally, the A is in the S, between the S's. Which means then, when I'm talking about angle side angle, oh no wait, oh just side side, I said, the angle literally sits between the two sides. Okay? For the other two, here's an example of side 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 on the left-hand side. Try to give you a visual example. Here's the difference between angle angle side and angle side angle. Here, you're given two angles both times, right? On the left, that side is not in between the two A's. The S is not in between the two A's, right? So literally, if I put my fingers on my angles, that side is not between my fingers. Over here, the S is between the two A's. So if I put my two fingers on the angles, the side is literally in between my two fingers. Do you see the difference visually? All right, then here's another example of hypotenuse leg. So what we're going to do is we're going to look at some triangles, decide if they're congruent, and if they are, we're going to figure out why. Okay, so you have the list and you have some visual examples. So here's our first one. So the question is, do we have three congruent parts? Yes. Is it an acceptable combination? Meaning we don't want to swear, we don't want AAA. Yeah, what do we have?
We actually have
Side, 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 right? So our triangles are congruent by side, side, side. I will always verbalize the full word like side, 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 but I'll always just write like SSS. Okay, and that's very acceptable everywhere. All right, so let's finish our congruency statement here. Triangle ABC is congruent to what? So what matches up with A? X. What matches up with B? And then C. Good? All right. Next one. Next one. So first of all, do we have three congruent parts? Yes. Is it an acceptable combination? What do we have? Good. We have two sides and the angle in between it, right? Side, angle, side. That's called the included angle. All right. So what matches up with C? G. What matches up with A? O, and then D. Thought it was going to be dog. All right. Next one. Do we have three congruent parts? Yes. Is it an acceptable combination? It is not. This would be an angle, angle, angle. I don't know enough to say that they're congruent. So these, as far as we know, are not congruent. Remember, we can't use AAA. Good for that one? Yeah. Okay, next one. Do we have three parts? It's an acceptable combination. Yeah, what is it? Good. Our side is not between the angles, right? So it's angle, angle, side. Okay, so what matches up with G? C. What matches up with J?
U.
And then
V.
V. PUV.
Yeah.
All right, next one. Do we have 3 parts? Is it an acceptable combination?
But to imply it.
Okay, so keep in mind, hold on 1 second. You need to address this. These are the same thing. The order does not matter whether you put it forwards or completely backwards. Okay, so you can't have either one of those. All right, so neither one of these work. So this is not an acceptable combination because we don't know that we have a right angle. Okay, so these two we cannot say that they're congruent. Okay, next one.
Yes.
Yes, they are congruent because of angle, side, angle. So the side literally sits between my 2 fingers, right? So my fingers on the angles, sides in between. All right, so what matches up with W? F. Then X goes with E, and then D. Is that okay?
No, you look bad, Will.
Okay, 2 more, guys. Do we have 3 congruent parts? No.
Yes.
I hear some yes and no.
Oh, yeah.
Okay, so there's only 2 more, but because we're such good geometry students, we also recognize that we have vertical angles that we know are congruent. Hold on, guys. All right, so now do we have 3 congruent parts? Yes. So are they congruent? This is the side angle side. So what matches up with A? C. What matches with B? D, and then E. Is that okay? C, D, E.
Okay, the next one's kind of.
All right, last one. Last one.
It's not as obvious anymore,
I don't have much marked on this, right?
but we know it's right angle.
Okay, so I do have a right angle, so I should be on the lookout for hypotenuse leg. Okay, now here's something that's different. Notice the triangle on the left and the triangle on the right, they share this segment XZ. It has to be congruent to itself. Okay, now think back in algebra when you were learning all those numerical properties, like the reflexive property said A was congruent to A, which seemed really stupid back then because of course 2 is congruent to 2, right? Or equal to 2. This is one of the reasons you learn it. Because we use it all the time because they share this segment. It has to be congruent to itself, but that segment's used for the triangle on the left as well as the triangle on the right. So we say that it's congruent to itself, which is the reflexive property. All right, so now we have a right triangle, right? Do we have a hypotenuse and a leg?
Yes.
Yes. So this is going to be, these triangles are being congruent because the hypotenuse leg, what matches up with W? Y, what matches up with X? X, and then Z. Okay, so here's what you're going to do for homework. On Google Classroom, listen, on Google Classroom, I have set the triangles for you to compare and decide if they are congruent or not. Okay, so for instance here, when we look at this, I have 2 angles and they share this side. So is angle side appropriate? Yeah. I'm not swearing and it's not AAA, right? So I'm going to type in angle side.
We don't like to.
It'll turn green if it's correct. Okay, now listen. Hold on, guys. You have to keep them, just for this, you need to write angle side and not side angle. If you were taking a test and you were side angle, that would be okay. Okay, but angle side just so that it turns green. If you have a scenario where they're not congruent, type in NC for not congruent. Okay? So this is just a practice with those shortcuts. Any questions on that? All right, go to it.
Let's go free.
Wait, so you didn't send me your last one a few weeks ago or months ago?
No.
And who's else about that I do?
I don't know.
No,